With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello friends, now we are going to see the solution for the given question. In the given circuit, when switch S is opened, the plates are uncharged and or separated by distance D is equal to 8.0 millimeter. Battery is of 100 volt and springs are identical with spring constant K. Capacitance of a capacitor with a separation D is equal to 8 millimeter is 2 microfarad. Okay, so it's 2 microfarad. When switch S is closed, the distance between the plates is reduced to 4 millimeter. Find the sum of the spring constant of springs. Okay, they have given this circuit. Okay, so in this circuit, the switch is open. Okay, so this is the switch. So when the switch is open, plates are uncharged. Okay, so plates are uncharged. The distance D will denote the 8 millimeter. Okay, so this battery will give the 100 volt. Okay, so 100 volt supply, and then springs, these springs are identical with the spring constant K. Okay, both the spring are identical. And then capacitance. Okay, so capacitance value they have given that when distance is 8 millimeter, the capacitance is 2 microfarad. Okay, and then when the switch is closed, okay, so switch is closed, the distance between them, the plates are reduced. Okay, from 8 millimeter to 4 millimeter. Okay, that means when switch is closed, okay, so when switch is closed, the distance will reduce to half. That means D is reduced to D by 2. That means the new distance is D dash when switch is closed. That is distance will reduce to half. 8 millimeter become 4 millimeter. Okay, and we want to find out the spring constant sum. Okay, we want to sum up the spring constant of both the springs. Okay, first of all, let us see the capacitance of the new distance. Okay, when the switch is closed, the capacitance becomes E dash is equal to epsilon naught A divided by D dash. Instead of D dash, substitute the D by 2. So we will get 2 into epsilon naught A divided by D. Okay, and then in next step it will become C dash is equal to 2 into epsilon naught A by D is the capacitance, so C. Okay, and then C dash is equal to 2C. Okay, and then let us find out the charge here. Okay, so charge Q is equal to CV. So here the capacitance C dash, so C dash V. So in next step Q is equal to C, instead of C dash we will substitute 2C, and 2CV is equal to 2 into, they have given the capacitance value as 2 microfarad, so 2 into 10 to the power minus 6, and then battery V is equal to 100 volt, so 100 we will substitute. For the, finally we will get the charge value as 400 microcoulomb. Okay, and then for one spring, what is the force? We will find out using the formula of force. Okay, so force formula, F is equal to Q square divided by 2 epsilon naught A. Okay, and then in next step substitute the Q for Q, then we will substitute in terms of capacitance, that is CV. Okay, so C dash VQ is equal to C dash V whole square divided by 2 epsilon naught A. And then next step, instead of C dash we will substitute 2CV. Okay, so 2CV whole square divided by 2 epsilon naught A. Okay, and then in next step it become we want to square that, we will get 4 C square V square divided by 2 epsilon naught. Okay, so 2 epsilon naught A, and then in next step just cancel it, and here we want to multiply by distance and divided by distance, we will get 2C square V square divided by epsilon naught A divided by D and multiply by D. Okay, and then in next step it will become capacitance is C. Okay, so and 1C and 1C will get cancelled, so finally it have 2 into C into V square divided by D. Okay, so this is the value of a formula for force for single spring. Okay, and then next we will write the stretches. Okay, so for one string stretches by the distance x is equal to d by 4. Okay, so the distance will the quarter, it will become quarter when we the string will stretch. Okay, so the formula for f is equal to, we have no kx. Okay, we want to find out the spring constant k, that is k is equal to f by x. Okay, so for f we have find out the formula, so let us substitute this. That means it is equal to 2cv square divided by d, okay, and then whole divided by, for x we want to substitute d by 4, so d by 4, and next step it will become, okay, and next step it will become k is equal to 8cv square divided by d square, okay, and then we want to fill out the value, okay. So data 80 into capacitance 2 microfarad and then voltage 100, okay, and then divided by d square. D, the distance d is 8 millimeters, so d square, so 8 into 10 to the power minus 3, we want to change into meter and square it out, and then finally after calculation we will get the spring constant value for a single spring, that is k is equal to 2500 Newton meter. In question they have already said the springs are identical with spring constant k, so the spring constant is k for both the springs. So we want to find out the sum of the spring constant. K plus k is equal to 2500 plus 2500. We will get the final answer as 5000 Newton per meter. This is the solution for this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.